Bismillahirrahmanirrahim. In today's video, we'll be discussing difference amplifier, which is also called differential amplifier. And this is from chapter 5 of circuit analysis book by Mr. Alexander and Sadiku. Now, I have a couple of videos on this, so this may look like a repeat. But since I'm making this video in Urdu and Bengali language, so I thought, why not make it again in English? So let's see, just let me know through your comments. There was something new that you learned. Okay. If you recall, in the operational amplifier, current does not enter into the circuit. That is one assumption or one fact that you have to keep in mind. The other fact is that VA is equal to VB. That is, this junction voltage VA is equal to junction voltage to the other terminal VB. Okay, now according to the definition, a difference amplifier is a device that amplifies the difference between two inputs. So these two inputs, and the difference of the two input is this one signal noise. This is pure signal, this signal with noise. So the difference we get noise signal, and then we can amplify this value. It amplifies the difference between two inputs, but rejects any signal common to the two. So it is all, you can see it is rejecting both the signs, and it is only getting the noise out. And you will subsequently learn that in communication system, we use various feedback mechanisms through which we feed the noise to reduce the noise. Okay. So in studying difference amplifier, we'll use this circuit. And you can see these are the two inputs. Resistances R1, R2, R3, R4. The output voltage V out. And two nodes VA and VB. And we need to derive equation for the output voltage V out. So first of all, we mark the current direction. We can assume any current direction. Okay. Now we apply KCL at node A. So current entering is equal to current leaving. I1 is equal to I2. And this, in terms of voltage, we can write that V1, current is flowing from V1 to VA. So V1 minus VA divided by R1. In the second case, the current is flowing from VA to V out. So VA minus V out divided by this resistance R2. And we can manipulate, we move R2 on this side and try to arrange the terms, like terms we have arranged, and further taking common. So this is our one of the equations that we are getting from VA, from node A. Let's see node B. At node B also, the current entering is current leaving. And writing the voltage equation, V2 minus VB divided by R3. And VB minus ground or 0 divided by R4. Here also we're manipulating, moving this to the left and opening the terms, collecting the like terms and taking common. So from here, this is VB, which can be further simplified to this form, R4 divided by R4 plus R3. So if you take common, then R3 will cut. So this is our second equation. And now we know that VA is equal to VB. We have to keep this in mind. Substituting equation 517 into 516. So for VA, we write this value, which is of VB. So we get the new equation here. And here also we'll just manipulate. I hope you can follow. Further. So we get this answer. So this is our final answer that we can use in solving questions. Now, two interesting facts we'll discuss. First one is that if we take R1 equal to R3 and R2 equal to R4, then what will happen? So we'll plug in these this values. So R1, R2 remains same. R3 will become R1 here. R4 will become R2. So this term. And now numerator, denominator same. So they'll get cancelled. So we have R2, R1, V1, V2 minus R2, R1, V1. We take common R2, R1. So we get this answer. So this answer is when we take R1 equal to R3 and R2 equal to R4. There's another possibility. What if we take these two to be same? So let's see. If R1 and R2 is same and R3 and R4 is same, from here, again we'll plug in these changes. So R1 and R2 is also equal to R1, so R1. R3 and R4 is equal to R3. So now this will become 1, and 1 plus 1, 2. 2 divided by 2, R2 divided by R1, and R2 divided by R1, but R2 and R1 are same, therefore this will also cancel. So this cancels, this cancels, this cancels. So what is left is V2 here and V1 here. So this is another answer that we can use. Okay, so let's see the example. The first example 5.7 says, design an open circuit with the inputs V1 and V2 such that we get this output. So I hope you remember what was the output formula that we derived. Might have to remember this, manipulate or keep it in your cheat sheet. Okay, anyway, now here we have V2 first, V1 later, but in this case V1 first and V2 later. So we'll just transpose these. So we get 3V2 minus 5V1, and now we can see these two are same values, and similarly these two should be same. So let's take the right term, this one first. So R2 over R1 is equal to 5. From here R2 is equal to 5R1. The other condition is if we take the left term equal to 3, so this is equal to 3. And now we put R2 over R1 equal to 5 here. And this is R1 over R2. So it will be 1 over 5. So putting the value of R2 over R1. Here we get 5, here we get 1 over 5. And then we move this to the right hand side. And further simplifying, it's 5. And from here we move this to the right and 3 by 2 to the left. So this will be equal to 2. And from here R3 over R4 is equal to 1. And so we can write that R3 is equal to R4. And now we can select any value which maintains this relationship. So let's assume we choose R1 to be 10 kilo. So R1 10 kilo, then R2 will be 50 kilo. Similarly, if we choose R4 to be 20 kilo, then R3 will be 20 kilo. Now keep in mind that any value between 1 kilo and 1 mega can be chosen. Although this is not given in this book, but this is from the instrumentation. I've taught that course and there it is mentioned. that if you take any value less than 1 kilo, the chances of short circuit is there. So that is why we remain within this range. Our circuit now will look like this. R1 10 kilo, R2 50, R3 20, and R4 20 from here. Okay, now let's move on to the practice question. The practice problem is design a difference amplifier with gain 7.5. Okay, now we had learned these two conditions. In this condition, there is no gain, or gain is 1 actually. If you take these two commons, then gain is 1, and that is fixed. But in this circuit, the gain is R2 over R1. So this we'll use, and this we can equate to 7.5. We will use this circuit. The gain is R2 over R1 from here, which is equal to 7.5. So from here, if we take R1 to be 20 kilo, then R2 will be 7.5 into R1, which will be 7.5 into 20 is equal to 150 kilo. Similarly, since R1 is equal to R3, from here R1 is equal to R3, therefore we can say that R3 is also 20 kilo. And similarly, R2 is equal to R4, therefore R4 will be equal to R2, that is 150 kilo. And the design circuit will look like this: R1 20, R2 150, R3 20, and R4 150. So I hope you have been able to follow this. Please let me know through your comments. Thank you.